Welcome to the overview of the Impact Estimator for buildings. This is a very quick run-through of the use and features of the program for first-time users. Techniques on modeling buildings and viewing results will be covered in greater detail in subsequent tutorials. Once you've downloaded, unzipped, installed, and opened the Impact Estimator for the first time, you'll see a blank field on the right and a blank project tree on the left in white here. My project tree has 3 projects already loaded, so it's not blank. These are the sample files that I'll be using for this tutorial. You'll see for each project here we have some information in brackets after the project name. In this case, it's the percentage of global warming potential. That is the LCIA, or Life Cycle Impact Assessment measure, that I've chosen to display here. And it's basically a running count as you build your model up of what the GWP is as you add assemblies to your model. You see here, to comprise the 100%, we have different assembly groups here. We have columns and beams, floors, roofs, foundations, walls, and extra materials, and each of those have calculated the percentage of each of those effects that contribute to this 100% of global warming potential. And you'll see here, if I open a group, so I'm opening all the walls up, and I have 6 different walls here, and each of them contribute a percentage to the wall percentage of the total building. I've chosen global warming potential to show, but if you want, you can choose any of the other LCIA measures that we present in our results. Or the other option you have too is you can choose to show absolute values of each measure instead of a percentage. I'm going to stay with percentage for this example, but you have that option. So we've got, if you were starting a project from scratch, you go up here and do new. I've got some projects already started here, as I said, so this is what you would start with. This is your project level information. So you give it a project name, you choose a project location. That will determine things like operating energy grids and transportation grids for sourcing the materials that are used in the calculations. There's a building type here. I'm choosing the first one, commercial. This affects replacement periods of different materials. The only materials that do get replaced are windows, claddings, and roofing materials. And for a different kind of building, those might change those replacement periods. The building life expectancy, this is anywhere between 1 and 1,000. You can put in whatever year you want, but again, at 60 years, for example, if I put in 60 years and I've got a window that gets replaced every 20 years, I'm going to end up with 3 times the windows by the end of the 60 years. The 60 years also affects the operating energy calculations for the lifespan of the building. We enter annual operating energy consumption down here and multiply it by 60 years to get 60 years total for that. The building height is a number that's used in the calculation of the on-site construction energy, how high you have to lift materials. So the height from the bottom of the sub-basement to the top roof is what the height you would put in here. Gross floor area is not calculated automatically. That's a number you would put in yourself, and it is only used in the graphs if you choose to do graphs on a per meter squared or per foot squared basis, on an area basis. The units, you can choose metric SI or imperial. I've got imperial for this example, and you can put in a project note and a description here. Operating energy consumption. This is the annual operating energy consumption dialog box. This is not an energy simulation tool. You have to do the energy simulation in another tool. And from that, you'll typically get results about the quantity of fuels or energy that is used on an annual basis. And so we've entered here. And for this example, we've got 1788 meters cubed of natural gas per year and 35,436 kilowatt hours. So I'm going to leave that as is. So that's how you start. That's you set up your project. You click OK. I'm going to click cancel just to save a little bit of time here. And then you need to start building your building up. And as I said, this is already complete, but let's go through an example. I'm going to choose this exterior wall here. You open up the assembly dialog box, and this is what you get. You give it a name. And with all assembly dialog boxes, the idea is you don't have to be a structural engineer to be able to model a building. You just need to know the geometry of each assembly, i.e. the size. And you get that from a set of plans, for example. So in this example, we've got 350 feet of wall times 10.3 feet high, and that defines our geometry, the wall area, essentially. We've got different wall types down here. In this case, we're doing a steel stud wall, which I've already created. So I'm going to click on that. And when I open up that box, it's going to ask me, okay, is it a load bearing or a non-load bearing? Do we have a sheathing type? No. The stud spacing, the stud weight, and the stud thickness, which is the stud size. So this is, if I change to imperial, this is basically 1 5/8 by 6-inch studs with heavy gauge on 16 inches on center, no sheathing, and a load bearing wall. So I click OK there, and that determines the structure of the wall. The other choices up here are opening and envelope tabs. If I click on the opening tab, this is where you can define your windows and doors. I've got, in this case, I've got 44 windows with a total area of 811 square feet. You can choose fixed or operable windows with and your frame type. So in this case, I've got aluminum window double pane frames with other choices, double and triple pane sizes. You can choose your glazing. In this case, it's a double glazed, no coating, air filled. But we have double and triple glaze other options you can choose. I've got 4 doors of a solid wood door, exterior door. So those are and there are other options for the doors here as well. So I've chosen the door and window types. The other tab up here is envelope. I can click on envelope, and you can add a whole bunch of different envelope materials to the wall. So there are claddings, gypsum board, insulation, paint, vapor barrier, etc. There's a whole bunch of choices. And in this case, I've added fire-rated gypsum board, 1/2 inch of 6 mil polyethylene vapor barrier, another layer of gypsum board, 1/2 inch regular, an air barrier, a Tyvek type material, extruded polystyrene, exterior insulation, and I've got brick on the outside. So those are the envelope materials of the wall. I've defined my openings, I've defined my geometry and my structure, and I'm going to click OK. That saves the assembly, and I've got my exterior wall added. And you go through each assembly group and each individual assembly, and you keep adding pieces until you come up with a final model for your building. Another thing I'll mention at this moment too, each assembly box has a help button down here. You click on that, another form will open up. If I make it a little bit bigger here, you'll see there's instructions for this help file. Bunch of information if you have questions about what you're supposed to fill in. I'm not going to go through it all now, but every assembly box, pretty much every dialog box in the tool has a help file to help you along with questions you might have as you're modeling your building. Okay, so that is one way to model a building. The other way is if you have the list of materials, your bill of materials from a CAD program, if you want to export that list of materials from your CAD program to an Excel file, you can import that Excel file into the Impact Estimator, and it'll populate the model with your already calculated material totals. And the way we do this is, I've got an example here. This is the same building, but here instead of all these different assembly groups with different assemblies modeled, I've done it once with what we call project extra materials. And if I go in here and I see here, this is a list of all the materials that if you wanted to, you could type them all in by hand, but this bill of materials import option lets you do it from an Excel file. And this is the same amount of materials as is calculated in the previous example, but just listed as each individual material. And the way you do that is, for that project, you right click on the project name and you look at this BOM file import, bill of materials file import. And I'm not going to go through this at the moment, it takes too long, but the idea is you find your Excel file, you load it up and you have your list of materials here. You have to map the materials, the material names that are in your Excel file to the materials, so they match the material names in the Impact Estimator. And then you click Go, and as I said, it automatically populates this list of materials for you. And that's the idea of the bill of materials file import. Again, there's a help file here with lots of information, and there are other tutorial videos on our website to help you along with that. But the procedure is all lined out there, and the idea is that you can get a much more accurate count of each material from your actual design in your CAD program than we could try to reproduce by doing these assembly diagrams up here, these assembly groups up here. So we've got a building modeled. We're ready to go and look at some examples. So right here, you press the reports button here and you get the reports table. Got several choices here. The first thing we can do is create a bill of materials. And you'll see here, I've got a bill of materials. This is a tally of the total of our building model. I happen to have chosen that project with the imported bill of materials. So in fact, the materials are not presented in their assembly groups. All of the materials happen to be in this Project X Materials column over here, all of the totals. If I go to our first project and choose that and do the bill of materials, you'll see it's the same amount of materials, but it's divided by the columns of beams, materials, floors, foundations, etc., etc. The next main results are our Lca results. And we've got detailed and condensed reports. I'm going to show you the detailed reports. So I've chosen detailed here, and I click Show Reports. And our table comes up here, and I'm going to maximize it just to show. So here we have our LCIA measures that we're presenting. Global warming potentials at the top. That's the one we've been talking about. The units in kilograms of CO2 equivalent. And then it's presented by different life cycle stages. So we've got our project phase, construction phase, our use phase, our end of life phase, and our building life phase with beyond building life phase, excuse me, and total effects A to C and A to D. Another option is to present the results by assembly group. So I click here, assembly group, and again I hit our report button, and I'm going to enlarge in here. And you see these are the same results, but instead of by life cycle stage, they're presented by different assembly groups up here. Each individual report is exportable to Excel, PDF, or Word, but to make things a little bit easier, we've got this export function up here, which can give you a project report, which is, I'll show you in a second, it's a summary of your building model in the PDF format. And the more useful, I think, report here are these life cycle effects reports to Excel for the selected project or all projects. And what that allows you to do is to, instead of exporting each individual report, it exports them all for you to an Excel format. And then you can start manipulating the data from your model in Excel, which is eventually what everybody does. If you want to put it into a report or you want to add some things to the results, that's the way you do it. And I'll just show you this sample building for the moment here. And you'll see here, this is the export to project report. And it gives a bunch of information, a table of contents, and software information. Maybe I should increase the size a little bit here. System boundary information, project information. So here's our energy consumption data, results. Here are our tables. There's our condensed table of LCIA results. Here's our detailed table. There's the results from A to C modules, the results from A to D modules, graphs for each different summary measure, embodied carbon calculations. This is the embodied energy versus the operating energy graph pie chart, which I didn't show you in the tool itself, but we produce the same type of information in the tool. Here's the bill of materials, and that's it. So it's really just a way of quickly exporting all the information from your model into a presentable form, basically. Our other options with reports are to do some graphing and project comparison graphs. So here we do project comparison graphs, and I can choose 2 buildings. So I've got two of these projects here, sample building and sample building number 2. They're the same model. This is what one of the main purposes of the tool is to do is I've made some changes to sample building 2. All I did was increase the amount of insulation in the roofing assembly. And the theory is you can calculate the resulting energy use change because of that extra insulation. And then you want to compare the results together. So I'm just going to do a quick comparison of global warming potential, and we're going to hit show reports, and here's this graph. So we've got our sample building in blue, our sample building number 2 in orange, and you'll see this is the product phase. That's the amount of materials, the embodied materials in the model. And like I said, I've increased the amount of insulation. So you'll see here, sample building number 2 has a little bit more in the material section. It's got more effects, we've got more material. But we've saved, by doing that, we've saved some energy. And so our operational energy over here is less in the building number 2. And you'll see overall here, we end up with less, instead of 78,000 kilograms of CO2, we end up with 730,000 kilograms of CO2 over the lifespan of the building due to the decreased energy use, even in spite of the extra material use. And that's the nub of the tool. What we're trying to do is to make design decisions and figure out how those design decisions affect our results, and hopefully go forward with trying to reduce those effects. The other thing we can do are these rating systems reports. They're geared towards green and LEED. You can do a separate report for each separate project, but the essence of the LEED report is, and Green Globes, is to compare different designs between your reference building and your proposed building design. So again, we've done this reference building as the sample building. Our proposed changes are the proposed building, and if I hit show reports, then I get a LEED compliant, or not compliant, but in this sort of format that LEED wants to see it. And you'll see here we've got, okay, our proposed building has less effects here than our reference design here. So our reference design is at 100%, and then we've decreased all these different measures by that amount, and then it's in a table here. And that's the kind of information that the ratings reports want to know. That's how they determine credits, is if you've made an improvement over a reference design. The other option here is a LEED building report, and I won't click it here. I have one built up for it, and I'm going to bring it over here. And this is a Word file, and it's sort of similar to the project report from before, but includes what we think. There's no official LEED submittal form that we know of, but this is what we think is the information you need to know. So it's got your building information, it's got your whole building Lca results, it's got information on the construction elements that are included, the functional equivalent, et cetera, et cetera. It's got areas for you to enter some text for yourself, because generally you have to provide some sort of narrative with your LEED submittal about why you made changes, what changes you made, et cetera, et cetera. And it gives you the version number of the software and that sort of thing, the kind of information that LEED wants to know and to check on. So that's the idea of that. It makes it a little bit easier to report with. And that's about it. It was a quick just show you we have to make a model of the building, we have to produce some results, and we want to make changes to a building and compare those results. And that's the whole idea of the tool. The subsequent tutorials on the website here will show you individual details about different assembly groups and techniques and the bill of materials import and etc. And we encourage you to take a look at those videos. Thank you.